Good morning, everyone. Today we're going to be looking at variable manipulation tips. Since we're going to be working with formulas, sometimes the variable that you want to solve for is not on the side where you need it, or it is not isolated, so you have to do that. Variable manipulation tips come in very handy for isolating the variable for which you want to find a value for. Now, you've learned these tips before in your algebra classes, but I'm just going to refresh your memory today because I know some of you are probably like, I don't remember a lot of that stuff. So we're going to look at it. The very first thing you learned in Algebra 1 is that in order to maintain an equality in an equation, whatever you do to one side, you must do to the other side to maintain the equality. So, for example, if I want to double this side, then that means I must also double whatever is on the other side in order to maintain that equality. So if I double this side, I double that side. That way I maintain the equality. Okay? Another example, if we look at this, t equals the square root of L over G. All right, let's suppose that I wanted to get rid of the radicand. Well, in order to get rid of the radicand, I have to square it. As you know, squaring gets rid of a radicand. But if I square this side, then to maintain the equality, I have to square the other side as well. So if you square one side, you gotta square the other. That's the only way to maintain the equality. Lastly, let's suppose we had a formula like this. Okay? And let's say that I want to subtract 3y from this side. So I would say 2x plus 3y minus 3y. But if I subtract 3y from this side, I have to subtract it from this side as well to maintain the equality. So subtract it from one side, subtract it from the other, maintaining the equality of both sides. All right, so that one's pretty simple. Everybody remembers that one. I mean, that is just the first thing they teach you in Algebra 1 about equations, is what you do to one side, you have to do to the other to maintain equality. Let's take a look at the second tip. If you want to move a term to the other side of an equation, you do the opposite of whatever it's doing on its original side. For example, if we go with the formula we were using right above, and let's say that we want to move the m to the other side of the equation. Well, right now we're dividing by the m. Okay, that's what it's doing right now. So in order to get it to the other side, we have to do the opposite. We have to multiply it on the other side. So we say m times a. And there you go. You've multiplied it over. And now it's on that side. All right? So we divided on this side. We multiplied on this side. Okay? And that gets it over. Another example. This happens to be the formula for a charge moving through a magnetic field at some speed. And let's say we want to get the v to the other side. Well, right now we are multiplying by the v. Okay? So to get it to the other side, we have to do the opposite, which is divide. So we would end up with f over v equals bq. All right? So now the v is on the other side. It's just doing the opposite of what it was doing before. It's dividing instead of multiplying. Okay? So whatever you do, whatever it's doing on its original side, you do the opposite on the other side. Here's another example. Okay? Now, let's say this time we want to move this entire term over to the other side. Well, right now it's being added. So on the other side, what do? You got it. You're going to subtract. You're going to say d minus 1/2 a t squared equals vt. And now it's over there. And we subtracted to do that, the opposite of add. Okay? So to actually move a variable from one side to the other, you do the opposite of whatever it's doing on the other side. Whatever it's doing on the original side, you do the opposite on the other side. And that gets it over there. Okay, the third trick we're going to look at is do the order of operations in reverse. Now, as you guys know, whenever you're doing order of operations, you always start with exponents, and then you do what's inside parenthesis, and you multiply or divide, and then last of all, you do any addition or subtraction. But that's when you actually stick numbers into a formula and stick them in your calculator. But what if you're just manipulating the variables? Well, a lot of times doing reverse order of operations to manipulate the variables is helpful, especially when a formula has more than one term on each side. Now, what do I mean by that? Well, this formula has three terms, a d, a v times t, and a 1/2 at squared. 1, 2, 3 terms, okay? And because it has two terms on this side, this would be a case where using reverse order of operations to solve for a variable might be helpful. However, I've got some others we're going to look at. So let's take a look. Suppose you had this one, 3y equals 2x plus 16. And let's say you wanted to solve for the x. Because we have three terms in this equation, reverse order of operations might be helpful. So where do you start? You do not start with the 2. You don't do that. The 2 is multiplying the x. But we want to use reverse order of operations. Is there any addition or subtraction? Yes, there is. The 2x is being added to 16. So the first thing you want to do is get rid of the 16. Because the 16 is being added on this side, you subtract it from the other side first. Okay? Now remember, we're solving for the x. Now, because we've looked at any addition or subtraction and there is no more, now we're going to look at multiplication and division. We are multiplying the x by 2, so now we divide by 2 to get it to the other side. And boy, it's raining out there. And look at that. We have correctly solved or isolated our variable x. So if we knew what y was, we could just chuck it in on the left side and get a value for x. Notice, did I move x to the other side? No. Why? Why should I move x to the other side? If I wanted to now, I could. I could simply say x equals 3y minus 16 divided by 2. But I don't need to. If your variable is in the numerator on the right side, leave it there. Move all the other things to the left side, just like I did. Okay, look at this example. This is actually the alternate equation. We'll be learning about this one before too long. Now, suppose we wanted to solve for this. Would we square root everything first because there's a square there and we want VF and not VF squared? No, we're going to start with reverse order of operations. Is there any addition or subtractions going on? Yes, there is, right here. We're subtracting v sub o squared from this. So let's first take care of that. Let's add v sub o squared to the other side. So we get vf squared equals 2ad plus v sub o squared. Now, what comes next? Any multiplication or division? Well, no, not technically, but a square is a sort of multiplication. So what we're going to do is we're going to get rid of the square by taking the square root. And if we do that, square rooting both sides, we get VF equals the square root of 2AD plus V sub O squared. Okay, and we did that using reverse order of operations in a very simple manner. Now, the next one is actually my favoriteest of all. And this is one that actually people really should get used to using. but they don't. And then I see them do the algebra incorrectly every single time when they have a formula or an equation with a ratio on one side. Let me show you what I'm talking about. This tip is called numerator-denominator switch. Now, don't write anything right here yet because I want to show you something. And you don't have to write this down. I'm just showing you why the tip is so helpful. Okay? Now, you guys, look right here. Suppose I had this formula. This is actually the formula for the resistance of a conductor based on its physical properties. Its resistivity, the length, the cross-sectional area. And let's suppose I wanted to determine the cross-sectional area. Now, a lot of times I will see people incorrectly do this. They'll think, oh, we got to divide the row L on the other side, and they'll say R over row L equals A. Well, dividing it to the other side is okay, but this is not. The A does not suddenly jump up into the numerator. It's actually 1 over A. And it doesn't help us any because we're trying to solve for A and it's still in the denominator. So don't try to get rid of what's on top if what you're wanting is on the bottom. Don't do that. Here's what you need to do. And this is what your algebra teacher taught you to do, but I'm going to show you a shortcut. Your algebra teacher said if what you want is on the bottom, first we have to get it out of the bottom. So we're going to multiply both sides by A. So we get A times R equals row L. Okay, because the A's over here cancel, right? And here's my A. So now it's in the numerator, right? We have to get rid of the R. We're multiplying by it, so we need to do the opposite on the other side. So we're going to divide both sides by R. This is what your algebra teacher showed you to do. And then these two cancel out, and that leaves you with A equals, boy, it's going out there, isn't it? A equals row L over R, which is correct. But I want you to notice something. From the original formula to the final formula, what have we done? Even though it took all those algebra steps, what have we done from up here to down here? All we've done is switch the numerator and denominator on opposite sides. That's all we've done. Now, if this is the process you have to go through every time when your unknown is in the denominator, and the end result is always the same, why don't you just go ahead and do the end result? Why do all this multiplication and division? Why not just say, oh, switch them? It's a lot easier on everybody if you do that. So look at these examples. Suppose we have A equals F over M again, very commonly used in physics, and we want to solve for the M. It's in the denominator. We need it in the numerator if we want to chuck numbers in and find an answer. So how do we do that? We're not going to get rid of the F to the other side. That would leave M in the denominator where we don't want it. No, what we're going to do is numerator, denominator switch. We're going to say M equals F over A. All we did is switch the numerator and denominator because that's the end result if you were to multiply both sides by M and then divide by the A. Okay? Look at this one. Period and frequency are perfect reciprocals of each other. So if we want to solve for the frequency instead of the period, we're going to do numerator-denominator switch. Just like that. Okay? Here's another one. This one's a little more complicated. Look at this. 3 minus x equals 16 over 2y. And we want to solve for the y. Now watch this. This is kind of cool. Do I have to move the 2? No, I don't. Watch this. I'm just going to say switch the numerator and the denominator, the variable that we want that's in the denominator. So we get y equals 16 over 2 times the quantity 3 minus x. And boom, that is correct. Okay? Isn't that a nice trick? And you don't have to go through those multiple algebraic steps that your algebra teacher taught you. It's going to be the same every single time. You're just switching the numerator with the denominator. So, why not just do that to begin with? The last trick is what I call the reciprocal trick. This is another way to get your unknown out of the denominator. It works a lot more easily for more complicated formulas, but I'm going to show you on some simple ones. If we use a equals f over m again, and we're solving for the m, think of the a as being over 1, and then you've got 2 ratios, and you can simply reciprocate, and you get m over f. So now the m is in the denominator, and you can continue to isolate that variable. All right, let's look at this one again. I used it a moment ago. Rho L over A, and we want to solve for the A. Think of the R as being over 1. So now reciprocate both sides. We get 1 over R equals A over rho L. Okay, and now if you wanted to solve for the A or to isolate it, since you're dividing by the rho L, you would multiply the rho L on the other side. Last one, and this is an interesting one. Suppose you have this. This is the lens formula, mirror and lens formula. You get 1 over the focal length minus 1 over the object distance equals 1 over the image distance. And you want to solve for the image distance. Now, here's a problem. Look at this complicated thing right here. What we want to do is reciprocate both sides. But in a formula like this, you absolutely cannot say f minus d sub o. F minus d sub o is not the reciprocal of this difference. If you want to reciprocate this difference, you have to reciprocate it as one animal. In other words, you have to say 1 over f minus 1 over d sub o equals d sub I when you reciprocate both sides. Okay? So you've reciprocated the entire animal. Now, you can write this another way also. This is kind of interesting. If you remember from algebra, 1 over x is the same thing as x to the negative 1. That shows reciprocation. So you could also say that di equals 1 over f minus 1 over d sub o to the negative 1, because that and that are the same thing, just like that. Okay? So there's some nice algebraic tricks that you can use to help you with solving for unknown variables in a formula. Thanks a lot. Bye-bye.